Slow. Okay. Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we are going to discuss about our lab 2, which is after pre-lab of lab 2. So this is our ladder diagram for task 1, and here we are from group 2. So this is our ladder diagram for task 1. Here we used start push button, stop push button, and 3 counter for counting the metal or non-metal material things. So here is our timer for 3 seconds when it's when the conveyor stop for 3 seconds, and the stamping cylinder will on for 3 seconds. The PA sensor will detect for that. So this is our counter 2 for counting the material metal things, and this is that product will go to the EP cylinder X, and this is our counter 3 for the non-material product. Okay, so here I'm going to run this. Okay, so you start. Already the operation started, and the motor already started also. So when the P sensor detect the stamping cylinder on for 3 seconds, and it's already counted for one product, and later if the sensor X detect the material things will go to the EP cylinder X, and if the sensor Y detect, then the material will go to the EP cylinder Y. So it's better to show in the CX designer. Okay. So, okay. So this is our CX designer. When we push the start button, the conveyor already turned on, and if the P sensor detect, so sorry. When turn on the push button, the conveyor started, and if the PS detect, it will stop for 30 seconds, and it will count for 1. And if the sensor X detect, then the PS cylinder will count 1. And if the sensor Y detect, then PS cylinder will count for 1. So that's all for that. And we are going to show our rest of the lab sheets. Thank you.
My turn?
Yeah.
Okay, thank you. So next is observation, discussion, and conclusion. For the observations, after we push the start push button, the system kick off with the conveyor motor initiating the operational sequence. objects passing through station 1 triggered a 3-second conveyor halt for a precise stamping process using an electro-pneumatic cylinder, and product counting occurred at this stage. Station 2 excelled in metal object sorting, activating electro-pneumatic cylinder X based on proximity sensor X identification. Simultaneously, Station 3, using proximity sensor Y, employed electro-pneumatic cylinder Y for non-metal object, for example, plastic, wood, and so on. The cyclic process continued until the stop PB push. For the discussion part, the system excels in precision and efficiency. Began in the deliberate pause at station 1 to ensure accurate and synchronized stamping processes, thereby preventing errors. Material differentiation at station 2 and 3 showcases a sophisticated sorting mechanism vital for handling diverse materials in industrial settings. The system modular design featuring distinct station for specific tasks, enhanced adaptability, facilitating seamless for integration of additional functionalities or modifications to meet evolving production needs. Plus, conclusion. In conclusion, the observed system showcases a well-designed and efficient operation for sorting object based on metal or non-metal. Also, the learning outcome also have been achieved, which is to design a program for HMI. Next is to design PLC ladder, and last but not least is demonstrate PLC HMI like what my member just do just now. That's all. Next. Thank you.
Hello?
Great.
Anybody hear me?
Yeah.
Yeah.
How to stop? Okay. Thank you.
Okay, now it's my part, which is the task 2 for lab 2. This is the figure 2 that I will make with the programmer and designer. I don't need more explanation. Okay, let's jump to the ladder diagram. Okay. Be with the designer will be better. Okay. So here we can see the designer and the programmer that has been made to suit the condition and the situation given by the task 2, which is when the first button start press and the operation will start, which is the water tank will be filled by the inlet outlet. The inlet until it reach the percentage which is 100%. And here the 100% mean the high level sensor, and then it will drop to the 25% of the water tank, which is a low level sensor. And here is the ladder diagram show. Here is the main operation, and then when you start, the high level sensor will start to operate. Then the outlet valve, the inlet valve will start to operate, and then the binary increment will start to count. when here is when it decrease is mean the here water tank is decreased until the low level sensor sense, and then it will start to increase again, which is the outlet valve here. Outlet valve here is for the low level sensor function. Here is the high level sensor function ladder diagram. And then this is the move ladder diagram, which is transferring the data between here to here. And then this is the total operation. And then to stop the whole process, we will just need to press the push button stop. And then this operation will remain, which is stop. Okay, that's all.
Okay, thank you.
Hello guys, can you all see my window?
Yeah.
Okay. So now I'll be talking on task 2's observation and discussion. So in task 2, throughout the simulation of the liquid level control system, the PLC and PLC HMI program demonstrated precise and reliable control over the liquid level within the tank. Initiating the system with the start push button consistently triggered a sequence of actions. The program effectively managed to inlet valve and promptly opening it when the liquid level was low and closing it when the level reached the high point. The synchronization between the PLC and HMI component facilitated smooth transitions, ensuring an organized flow of liquid. The cyclic operation triggered by the start and stop PBs was executed flawlessly, highlighting the program's responsiveness and consistency. So discussion for our part task 2. The successful simulation emphasizes the importance of careful control in industrial automation. The program's ability to accurately manipulate the inlet and outlet valves ensures a controlled and adaptive response to fluctuating liquid levels. The level of precision is crucial for industries where maintaining specific fluid level is top. The cyclic operation reflects real-world scenarios, showcasing the potential for increased productivity and reduced manual interventions. The task enhances our understanding of PLC HMI integration, emphasizing the creation of intelligence control systems for practical industrial applications. The experience gained in troubleshooting and refining the program equips us for the future challenges in realm of industrial automation. So now I will be discussing on overall discussion for task 1 and task 2. In the course of laboratory work, our team successfully designed and simulated two distinct PLC HMI programs for different industrial applications. One is a sorting system and another one is liquid level control system. Through the utilization of Omron CX Programmer for PLC programming and Omron CX Designer for HMI interface development, we were able to achieve the specified functionalities for each system. For task 1, involving the sorting system application, our team demonstrated an understanding of conveyor control, object detection, and sorting mechanism. The PLC HMI program initiated the conveyor motor open, pressing the start push button. At station 1, the system effectively stopped the conveyor for a designated time, allowing for stamping process using an electro-pneumatic cylinder. The sorting process at station 2 and 3, triggered by a proximity sensor X and Y, showcased the successful activation of electropneumatic cylinder for sorting metal and non-metal objects into dedicated container respectively. For task 2, centered around a liquid level control system, exhibited our team's proficiency in managing fluid levels within a tank. Upon pressing the start PB, the system activated and the PLC HMI program controlled the inlet and also the outlet valve to regulate the liquid level. So we can conclude that this laboratory work provided our team with hands-on experience in designing, simulating, and troubleshooting PLC and HMI programs for industrial applications. The tasks allowed us to integrate theoretical knowledge with practical skills, fostering a deep understanding of the complexities involved in automation and control system. So that's all, guys, for discussion and conclusion part.
Okay, guys, so that's all. If anyone have any question, just ask in the group. No need to discuss.
Thank you, Bhavin.
Okay.
Enough, time.